Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
Hello, everybody. Welcome back. Welcome back. I'm Justin, and for this next hour or so, we are going to be talking about what developers get wrong about application quality. Now, the things that I've done this last year to up my application's quality are convert as much JavaScript to TypeScript as I could. We went from virtual private servers to having everything in Docker containers, and we doubled down on some of our error reporting. Now, let's see if I made some classic mistakes. Of course, you know your stack, you know what you've been doing to increase your application's quality. Maybe we'll even hear if it's actually kind of like a necessary thing we should do, or should we think about it in a different way? Anyway, we're going to find out soon enough. So I'd like to introduce you to our amazing speaker who's going to be sharing more about that in a second. Of course, you can ask questions to him, so definitely do that. And then at the end of the session, I'll go ahead and ask them for you. Our amazing speaker works for Splunk as a senior technical advocate, and his name is, of course, Chris Riley. Hello, Chris. Welcome.
Justin, thank you. That was an awesome intro, and I want to double click on what you mentioned about moving to Docker containers, because that's certainly one of the things that you should be thinking about here as you embrace application quality. And it may not even seem like Docker containers are a part of quality, but they are. So before I begin, I want to get you kind of in this mindset. So let's imagine that you get a chance to drive an F1 race car. They set you in the car. You have one of the most amazing machines in front of you to go fast. And that's the obvious goal, right? But before you start going, the first thing you say is, well, where's my helmet? And they tell you, no, you don't get a helmet today. And then you ask, where's my safety belt? Where's my harness? And they said, no harness. And you look in front of you and all you see is a country dirt road. Now, first of all, it's a country dirt road, so you're not going to go as fast as you'd like to. But second, are you going to feel comfortable driving that piece of machinery as quickly as you possibly can in that type of scenario? And that's really what I want to talk about today, because all of this is about the fact that developers are driven to build features. But we get in this trap where we only think about the features. The customer is the feature, not the actual end user. So we don't think about the end-to-end process of getting that feature inside of production. And after 150 plus interviews of developers, I realized that there's a lot of common gaps there that developers face. And these gaps are detrimental, number one, to their careers and career development. So my name is Chris Riley. I am a senior technology advocate in developer relations at Splunk. What does that mean? It basically means that unlike you, I could not make a career of application development. The last time I was a developer or a full-time career developer was in the area of .NET, and I was building optical character recognition software. So it was pre-DevOps days, etc. But I did experience the world of IT very heavily, and I decided that it wasn't my forte. My forte was really being engaged in the conversation about application development. So I'm a bad coder turned somebody who just could not give it up. And I will confess that this session is a lot about changing hearts and minds. And maybe you're like Justin and you do already think a lot about application quality, and that's great. And you can leverage this session as a resource with your peers in helping communicate that message. Maybe you're not there yet, and quality is an afterthought. Then I want to change your mind. Or maybe you just want to double down on application quality, which is what I would like to see in most organizations because they're lacking there. So what are the things that developers tend to get wrong about application development? The first half of this is really setting that mindset in going against these. And then the second part is exploring all the dimensions of application quality, like why are Docker containers a part of application quality? Well, the first thing I see is quality is often viewed as like a support activity, as something that you do as a necessary evil, like taking the garbage out. The other big thing, and this is why I talked about the F1, is that it slows you down. It's one of those things that's annoying. It takes you from building functionality, but that's really a myth. And I understand where this impression is coming from because it's so far removed from building functionality, but it is a myth. And finally, that it's somebody else's job, that you have a quality engineering team or a QA team, and it's somebody else's job. I do want to say that my focus is on quality engineering, not quality assurance. They are radically different practices. One is focused on automation and strategy. The other is focused on, clicking through the application and seeing what's going on. And that is an important distinction because every enterprise is moving in the quality engineering direction. And how I really encourage you to think is from this code to cloud journey. So don't think about your code in a silo in the functionality that you're building and you are required to deliver to the organization. Think about the path of that functionality all the way to the cloud and what that means for the end user. And why does this matter? Because shit happens. No matter what, things will break. Your application will break. It's 100% guaranteed. There will potentially be security exploits that are related to your code. It's going to happen. They say that the only thing certain in life is death and taxes. Well, death, taxes, and bugs in your code are certain. So because of that, it's better to reframe how you think about quality. And you should reframe it in these perspectives. First of all, quality is a feature. It is not something that you just do as a support function. It is actually a feature of your application. And how I know this is true is because of my experience, even in the last year, and my experience just joining this event, as a matter of fact, and I'll talk about that. It allows you to go faster with less toil. Yes, by focusing and leading with application quality, you will go faster. And there will be less toil, some people use the term shaving the yak, which is one of the weirdest industry terms. And I ended up adopting it. There will be less residual things that you will think about if you focus on quality. But a lot of you are here thinking about career development. And this is an absolute necessary component of advancing your career in the application world. And finally, you've probably heard of this term shift left. It's coming inside of Splunk. It is a huge thing. So as you think about shifting left, quality is a huge component of it. So let's first start with quality as a feature. In the last year, there were 3 separate applications that I had subscribed to and then unsubscribed to all due to application quality for various reasons. One of them was an online learning platform for my girls. So remote learning, wanted to get them the best possible content. What I found out is we subscribed to this service which had the best possible content. But after, I don't know, maybe 2 weeks, we just had to get rid of it. Why? Because the features were not performant. It wasn't behaving in the way that I expected it to do. And you could really tell that the engineering time behind the application was not as effective as they could be. Your application is a reflection of you and your team. It really is. And I'm sure you as a techie know you can open up an application and understand it's a window into the engineering team that built it. So you should realize that and always be thinking about that when you ship code. And that is why quality is a feature. User expectations are through the roof. I bought a rower because like everybody, you had to get the COVID weight gain off. And the content was great. The training, the exercise videos were great, but I had to unsubscribe from it. Even though it was built into the rower itself, I had to unsubscribe, and I switched to Apple Fitness because the quality of the application was not there. So missed expectations are the same as your application not working, period. It's not just today. Latency, slow button clicks are the same as your application being down. Second is I have to convince you that focusing on quality actually makes you go faster. The reason that we don't think about this is there's a time gap, right? When you're building a functionality and you have to stop to think about quality, it's painful. But then you have this time gap, the CI/CD process. Now you have to release the application, and then it goes into production, and then it's in production for some period of time. I promise you that when something happens in production that involves your code, the amount of time you're going to spend fixing it is actually much greater than the time you would spend fixing it early on. So addressing these issues early on actually costs the organization less money, but for you, more personally, less toil. In true calendar time, hours spent, unplanned work is the metric that we're talking about here. And it is absolutely true that focusing on quality will reduce that. So you just have to have that in the back of your mind. It's kind of like having a savings account or whatever retirement account you have. You have it there for the future because you need it. And so this is the same thing. You are banking time by focusing on quality early on. Also, what I've realized is that when people get on the paved road, not the dirt country road, they get more peer support. More peer support means that you get stuff done faster. You get to leverage the community of your peers to get stuff done faster. So by following best practices and focusing on quality, you get more of that support, which accelerates your feature development. And then this is a big one. Again, this term, shaving the yak. You will waste less time explaining to your peers how things work if you focus on quality, because you're staying within the guardrails, you're on the paved road, and everybody has a general, better understanding of how your application was built and what you are doing to ensure that it works. So you get less questions about that, especially if you're in a large organization who is focusing on AppSec or DevSecOps. You want less questions because they will shut down your build process and your sprint very quickly just to ask you some basic compliance questions. And I know for some of you, you want to think about career development. How do I become an engineering manager? This is all about quality, strategy, and understanding the business. You need to have a good understanding of how the functionality that your team is building relates to the increased user adoption, increased sales, whatever it is that your application does. Because by understanding that, it will dramatically accelerate your ability to move up in the engineering org. If that's something that you want. Not everybody does, and that is actually very noble. But if you want to advance your career, you need to move into a more strategic mindset. And thinking about quality is a strategic mindset, because it's not just about clicking buttons on a screen. It's about building a strategy, focusing on automation and looking further out than the functionality that you are building. And finally, before we go into the dimensions of quality, I wanted to talk to you about this idea of shift left. So I've talked to some developers who are like, yeah, shift left, I love it. It's great. Put me on call. That's kind of, it feels like an odd thing for anybody to want. And then I've talked to others like, that's never going to happen in our organization. You know, my responsibility is to go through my backlog, implement my features, and then I'm done. I'm good. I believe shift left is coming no matter what. Inside of Splunk, we're already there. Our SRE team is not supporting our applications. Our developers are supporting the services that they build. I think that this is the trend. It's going to happen, and our developers are on call for their services. Our SRE team is on call for third-party services. Shift left actually is less about the developer, the individual. It's more about efficiencies, because no organization should think about shifting left and just throwing all the responsibilities onto the engineering team. That's not going to be successful. So shift left is more about thinking in this idea that we should address issues earlier before they become dramatic problems or catastrophic issues in production. Back to what I said before, you address it now, then it's going to cost you less toil, money, and time than if you address it in production. It also means less work. So actually, you think that shift left, for example, if I am on call, then that means I'm going to get woken up when something breaks. You're going to get woken up no matter what. If it's your service, you will get called. It's just you're going to get called later. And so if you were the one brought into the firefight sooner, you will actually resolve the issue and take less of your time, which again is less unplanned work. I want you to think of this metric of unplanned work, because a lot of engineers have not spent the time to kind of quantify in their heads what unplanned work actually is and how much of their time they're spending on unplanned work. Another way to think about it is how many of your sprints in the last year have been pushed out. That is all unplanned work. All right, so that was me giving you a lecture, maybe scolding you. Care about quality. And the reason you should care about quality is you want to go fast. And by making quality a feature, it will help you go faster. Now let's talk about the actual, what are the dimensions of quality? It might surprise you. So when I say the word quality, you might just be thinking one thing: unit testing, linting, functional testing. You might be thinking about clicking in the application in the screen, which is not, what I'm implying here. So the way I look at it is there's really 4 with a 0.5 dimensions of quality here. So first is testing. So this is how you test the quality of your application. Very much a part of developer or your quality engineering team. Second is monitoring. You normally don't think of monitoring as an aspect of quality, but it absolutely is, because your ability to respond to issues, even latency or unexpected user experience inside of the application, is absolutely a part of quality. Another element of monitoring is incident response. So how do you get to the right person when something breaks so that they can resolve an issue as quickly as possible? And fourth is business metrics. How do you report quality? How do you justify what your team is doing over a long period of time? Not just a short window, not just one feature, one ticket. And then finally, this 0.5, because I couldn't make it 100% fit into the narrative of this presentation, is I want to talk a little bit about feature flags and the power of feature flags and what I see as an evolution there and how interesting that is. But I also want to use it as an opportunity to talk about what are your responsibilities as a developer when it comes to how you organize yourself. So first, let's talk about just application testing. There's a lot of different types of testing. I don't have all of them here, but the most common, everybody's kind of check the box. We do that. We got unit testing down. We got regression testing down. We're done. Code quality, yeah, we see a lot of organizations do really well with code quality scanning and consider things like best practices. And best practices are industry best practices, they're organizational best practices, things like naming conventions and so forth, making sure that engineering teams are consistent. Once you start to have 10 plus engineers in your organization, consistency across naming and organization of code matters a lot. And it actually impacts hiring, it impacts change, it impacts a whole bunch of stuff. Security. I didn't talk a lot about AppSec or DevSecOps, but it's coming fast and furious. All you have to do is watch the news and see the amount of delivery chain attacks that have been a part of vulnerabilities in production. You don't want to be a part of that. Certainly, you should hopefully live in an organization that is a blameless culture. But there are so many things that developers can do to prevent that kind of stuff. You will not prevent everything. It's about risk mitigation. And those are, again, code quality scans, vulnerability scanning, scanning artifacts, but also preventing operational drift. What is operational drift? Operational drift is when configurations and settings on your machine end up in production. It happens a lot. It happens due to repos. It happens due to lack of containerization. So let's talk about what Justin said, is that if you are running builds on your machine and directly on your machine, there is a good chance that configuration, all of these settings in Node and so forth can eke their way into production and be vulnerabilities because you're not thinking about this on your dev box. The configuration and the infrastructure on your dev box matters a lot. Moving your architecture into containers helps with that, but it doesn't 100% help with that. You still have to keep it in the back of your mind. I'll give you one example. If you're using Kubernetes and you have kubeconfig files, and inside of your kubeconfig files, which I would not advise as a best practice, there's a secret that you use in your application. Now, somehow that secret makes it all the way into production builds. It is now available. This recently happened. It wasn't a kubeconfig file. It was a different file. This recently happened in the news, and I'm not going to throw the company under the bus that this happened with, but it was catastrophic. So a simple thing like secrets management. I've seen developers put secrets in commit messages in repos. These are serious things that can dramatically impact the security of the application in production. Next is integration testing. Usually this is automated and you have your integration environments, especially if you're in a microservices-based application. This becomes very critical when you start to think about the broader application. And yeah, I don't see developers impacting this a lot. What I do see impacting is the best practice of when they decide to do pull requests and commits and so forth for their application, because that is usually the trigger for integration testing. Functional testing, what used to be manually clicking through the application and still happens to help create the test suites. We have now great real user browser testing, all of that good stuff. That you can leverage, and it's absolutely critical to validate the user experience, what we call real user experience and real user experience monitoring. And a part of that is synthetics. Synthetics testing is where you emulate the user experience in order to get a sense of what to expect, but expecting what they are going to expect, meeting those expectations that I said before. Now, all of these are so powerful because when I said earlier that testing is a part of your application quality, you could actually use this testing to improve the functionality and dictate functionality in your application. So to give you one example, last month we ran this game called OllieQuest. It was a very simple RPG single-page application written in Node. And we use synthetics to add new functionality and improve the functionality of the application. So we continuously were testing via synthetics the application, and we were doing all sorts of optimization for regions, for load times, etc. And what you see on the screen is just some screenshots of, you know, before and after, and how you're trending, and good and bad. And this also helps with best practices, because again, I said latency is the same as being down. If a page or an image takes too long to load, people give up, especially if they don't have to be there. There's some applications you have the luxury where they have no choice, they have to use it. But if they don't have to be there, then you really need to think about user experience. So this is an example of using testing and quality as a way to build functionality, as a feature of your application. Next, monitoring. That might have been the one where you kind of rolled your eyes and like, you know, monitoring is SRE team, cloud architects, operations. That's operations things. That's not me. It's changing. So you may have heard of this term observability. Observability is just monitoring, but it's the definition used to talk about modern monitoring. So all the considerations you have to make for modern distributed applications. There's a new type of data set inside of observability called traces and spans. So typically we'd think of logs. Okay, developers create logs. How you create logs matters a lot, but you kind of create them and that's somebody else's problem, right? Not really, but yes. So developers are responsible for creating logs, and hopefully high quality logs, so that those who are on call can address the application. Now we have, and then you have metrics that you can create on top of the log. So developers, yeah, you know, they care about latency and what we call red metrics, rate, error, and duration. Now traces and spans. So traces, that's the relationship between two services. So a service calls your service, your application, and then your application sends data to another service or back again. So the trace is those hops. So not only are we monitoring what happens in the service, we are monitoring the hops between services. And it's the entire transaction from the front end all the way to when you exit the application. So API gateway all the way to when you exit the application. Spans are what happens in the individual service. So the amount of time spent in the service and basically all the calls that happen in the service. These are all observability monitoring practices. What does this have to do with you? Well, if you're in an organization like Splunk where developers are on call for their services, then the developers are also responsible for creating the metrics that are used to measure the quality of that service. But also developers are responsible for instrumentation, and it can't be an afterthought. Instrumentation, the best instrumentation you can have in observability is instrumentation in code. So you have basically agents as layer 1, you have auto instrumentation as layer 2, and then you have in code. As you go down the chain, this agents are the easiest to implement and don't even need to involve developers. Auto instrumentation involves developers, but it's just a reference to a library. In code directly involves developers because you have to implement it. Now, in observability, developers are instrumenting all of this, even if it's a front-end application, because you want to see what happens in the entire stack. So developers are responsible for identifying tags, which tags are one of the key things to slicing and dicing your application when it breaks in production. And so because of this, to do this at scale, developers need to do it consistently and regularly and follow best practices, etc. So it's much more than just the logs. Also in this scenario, developers are responsible for creating SLOs and SLIs, service level objectives, service level indicators, because nobody knows your service better than you. Even if it's a front end, I know you might be saying, I'm a front end developer, it doesn't touch me. Yes, it does. You are taking data in and delivering something to the screen. So you have service level objectives and indicators as well. And those are used to build dashboards. So you are a part of monitoring. Your responsibility is to make monitoring more successful. Even if you are not the one on call, which you are always on call, whether you know it or not, you are responsible for the quality of what happens in monitoring. One of the things that I want to talk about around here is this open source project in CNCF called Open Telemetry. And this is a fantastic tool to help developers and organizations standardize their instrumentation for getting data from the application to the observability monitoring plane. Super powerful, good thing to know, good thing to encourage inside of your organization. Avoid vendor lock-in so that you're not tied, your application is not tied to the agent. This is where the developer is going to implement tags, spans, and traces, and all of it is it's not difficult, but you have to do it in a very meaningful way so that the output is really high quality dashboards. These dashboards would not exist without the developers meaningfully and accurately instrumenting observability. And so if you want to make your on-call and your SRE lives better, you have to do this, and you have to do it well. Because somebody's going to get called when it breaks. So first of all, if you're a developer and you write code, you are on call. You are always on call. If you have code running on production, you are always on call. You may not be the first one who is called, but if anything happens related to your code, somebody will find you. And that is, again, unplanned work that you didn't anticipate that you were going to do. So by helping create better context from the application to production, you make on-call suck less for you, for everybody. You help find the right person at the right time. And all of this is just to reduce MTTR. Everybody's spending less time resolving incidents, more time doing their job, which for you is building more functionality. And this is sort of what it looks like. So if you have a good incident response strategy, you get a whole bunch of context like dashboards all pushed to you, surfaced to you so that you don't have to go hunting. Maybe links to Confluence articles, run books, or whatever it is. So now this is the one that really, if you're thinking about career development, you need to also think about the business metrics. How do I tie what our engineering team is back to its impact on the business? So you're trying to align features, functionalities, and processes to business success. I'm sure, every engineering team, for example, has a hard time getting budget for tooling that they need. This is one way to help convince people to give you budget for what you need. It helps you improve velocity and quality over time. So instead of just looking at it as a piece of functionality, it's in production, let me move on, I'm just a factory of features. You're thinking about a series of functionality, its impact on the business, and how can you optimize that? Because if you do that, you are on a straight path to building and advancing your career as an application development. And you're also helping the entire organization measure technical debt and toil so that you have an opportunity to fix it. Because if you can't spot it, you can't fix it. One of the measures of success that has become very popular, and I kept on throwing out this metric that I personally really like, is something called the DORA metrics. The DORA metrics directly relate to what the developer does and how it gets into production. So we're talking about deploy frequency, lead time to change. So lead time to change is how long does it take you to get through your backlog, change failure rate, and MTTR. Now, the thing is, some organizations are setting this up and effectively measuring their engineering teams without the engineers knowing about it. But it's always much better for the engineers to be a part of this process. So being a part of implementing and getting good DORA metrics helps the engineering team across the board. But the data has to be there, and it's responsibility of the developers to make sure that the data is there. They have to be consistent in their naming conventions of repos, how they put their commit messages. Like ideally, you should be putting your Jira ticket number in your commit messages so there's a correlation between your repositories and the commits. So all of these are great. I really like the amount of unplanned work and also leveraging this as a tool to find technical debt in your repo. So looking at aging branches that have not been touched, because those actually pose a risk to the organization. And here's an example of a dashboard where this can come all together for MTTR. And you notice one big thing always jumps out at people is the cost of downtime. And that's just to show you that there's a real financial impact of what you do on the business and the impact of the business. And this is calculated based on your activity directly. So finally, I told you the what was it, 4.5 dimensions, feature flags. The reason I want to talk about feature flags, maybe because it was recently in the news, super powerful. I love feature flags, but I also have seen that organizations that don't think about how they structure their feature flags, total waste. Just don't even do it. Not even worth your time. Because feature flags change the whole bug paradigm. So do release automations processes like canary releases and CI/CD. Because you implement a feature flag a lot of times so you can test it to see what happens. And if it fails, it's not actually a failure. You turn off the feature flag and now you know, and then you improve the quality of the feature. But I also really like it is because it's a direct correlation between what you are building to the quality in production. So if you're leveraging feature flags, you're already in a quality mindset. But you have to structure it really well. And so this is both in encouraging you to use feature flags, encouraging you to structure it well, and realize that the correlation between what you do and what happens in production is direct, is one for one. It's not many layers deep. There's also this really interesting story that happened 2 weeks ago where Clubhouse clearly had a feature flag that was toggled on accidentally for everybody. And they gave away new functionality that some users found, and they really liked it. And they had to revert it. And it just shows you the power of feature flags. So that's why this is here. So I'm going to close out and just say, your application is a reflection of you. It is a reflection of your team that built it. It is important then to think about what happens in production, to have this code to cloud mindset so that you are thinking quality first, because that's going to help you advance your career. It's going to help you support the business, which also helps you advance your career. So thank you, everybody. Before we go into question and answer, I just want to say organizing events like this is very hard. I've had to do it myself in a small scale for DevSecOps days here in Colorado. And I want to thank everybody at WeAreDevelopers for inviting me here. And I want to thank you for giving your time. There's a ton of virtual content out there for you to spend your time on. And I appreciate you taking a bit of time with me. If you want to reach out just to say hi, or find out more information, or tell me I'm wrong, whatever it is, please do. I always like hearing from people who attend my sessions. Scan that QR code. It gives you access to all my various things, including podcasts. And now, if there's any questions, I would love to entertain those.
Thank you so much, Chris. I really enjoyed that talk. Also, nice to hear that I wasn't completely off course. So when it came to improving quality, which is always good, but I still have quite a lot to do, I think. Now let's go to some of the audience questions. Richard had a good one. He said, a lot of what you suggest seems to weaken the division of labor which exists, as not everybody is able to be an expert in all fields.
Absolutely.
Between codes, monitoring done by devs, core support, etc. How would you suggest incorporating this approach in a large product team? He says 40 to 60 devs.
Yeah. I like that question because that's the thing that I hear a lot. And if you remember 3 years ago, full stack engineer was the thing. It was full stack. Everybody's full stack, right? But nobody's full stack ever. So first, I want to say that shift left is not a career change or a responsibility change. It is about efficiency. So you can't shift left without giving developers more tools. That can't happen. But this comes from a very kind of visceral reaction, like, my responsibility is not what happens in production. But the thing is, it is. It impacts you no matter what. It will come and find you. So whether you're on call for your application or not, it will come find you. Now, the essence of this is like, it's going to take me more work to focus on quality than building functionality. And I hate to say it, yes, it does. You know, writing the test before you write the code and like all of this stuff is somewhat painful, but it's also to ensure that all that functionality that you build is successful. Now, how do you do this in large scale teams? Our engineering team is way more than 60 people. This is an expectation. Part of how you do it is your SREs. If you do not have an SRE function that is embedded in your engineering team, it's almost impossible. Why does it matter? Well, the SRE is the one who's your steward. They're your guide, right? They know that you want to build functionality. They don't want to slow you down. They are your guide to make sure that you think about these things so that it's not you always going, oh, I need to go and I need to do, you know, look for technical debt, or I need to think about refactoring. Or they should be stewards. They should be coming to you. The other thing that the SRE should be doing is what's called service onboarding and service maturity. So before you launch a service, they should be coming to you and be like, great, you have a new service. That's fantastic. Let's go through this checklist. You go through the checklist. If you make it all the way through, your service is ready to make it into production. If you don't make it through, then you have to do initial steps, which, you know, you intended to do, but you just didn't. So for a developer to sit there and constantly think about all of these things that they have to do is not effective. Like, you're not going to be good at building your functionality. The organization at large should be architected to support that. And from what I've seen, it's this SRE function that makes that most successful. At Splunk, our engineering teams are large. This is exactly how we do it. Our developers are on call for their code. Our SREs are constantly working with their developers. They spend a lot of their time just communicating with the developers to help to ensure that that application meets the quality that they expect and gets into production. So I hope that helps. I know that that's not always the answer that sits well, but that's okay. Not everything needs to sit well.
And then actually I had a question for you. If you could give some examples of service level objectives, just so we can get an idea.
So let me dig into that a little bit. So the way we do it, and the way a lot of organizations have started doing this, is everybody has standard metrics. It's usually 3 metrics. Everybody sees every service, everything. So every service has red metrics: rate, error, and duration. Maybe you've heard of the golden signals. At the service level, you're going to expect 3 to 5 metrics. Those metrics are service-specific metrics. Only the owners of that service are really going to understand what metrics matter. And they could be anything. If it's an API, it could be request limits. It could be, you know, all sorts of stuff that is unique to your application. If you think in terms of contracts, your service has a contract with the rest of the organization. It takes data in and it outputs data. So think in terms of what makes that contract successful. And those tend to be your service level indicators that drive your objectives, or vice versa. So that's one way to figure it out. The other way to figure it out is exploratory testing. Test your application, see what things do not meet your expectations, and those might be your service level indicators. That's another way to potentially create those. But again, the SRE function is there to steward and help the developer figure out what those are. They don't necessarily need to understand all of that right away. They will learn it, but the SRE should help the developers figure out what those are, because the service level dashboards are key to developers being able to support their applications. And you're not just looking at what could go bad, you're looking at what could go well as well, because you want to ensure user experience. So real user monitoring and synthetics are a tool to help figure out what those might be.
And then last question, or actually kind of like a comment from me, something I've experienced in the wild, and then I was wondering of what your look at it is. Of course, as any developer, I use a lot of open source tools, and sometimes come across bugs, and have been often too busy to kind of well, not too busy to fix the bug because, yeah, I need it to work, but I've been too busy to commit it back to the open source repository. And then a number of months later, I have to pull in the new version and then have all of these merge issues and spend a lot more time actually solving the merge issues than I did actually solving the bug. So I basically learned from my mistakes, and now I make an effort to always contribute back to the open source projects, and actually have recently got asked to become a core member of one of the open source projects that I use. I'm wondering if what you see with other developers that you talk to when it comes to open source.
Yeah, I think that's a common problem in open source adoption is critical. So there's a few things here. First, thank you for contributing back to the community, because that is ideal. And I know that that's difficult. There's a lot of ways to contribute back to the community. One could just be documentation, you know, and that has less direct impact on the code. But there's another element of this that I think is really important. When you build open source projects, I think it's also important for project owners to think about compartmentalization. So how do they make this code easy to run for other developers, such that they're not always dealing with the issues of, you know, merge conflicts and so forth. But also, when you say bugs, it makes me think they could be vulnerabilities. And so one thing that you know, organizations need to think about is how they structure their repositories and so forth for artifacts, and doing vulnerability scanning and code quality scanning as a part of the open source. And so I can't fix your merge issue, but I will say that I don't think that I feel like that is also should be a part of the CI/CD process to validate these projects, because you remember I was talking about operational drift. Operational drift is a silent killer. Like in healthcare, blood pressure is the silent killer, which is something, you know, I have high blood pressure, but it's something that it's a bigger consideration that the organization needs to take on, that they are also, as a part of you deciding to use this open source project, doing other things to make sure that there's consistency in, you know, the codes, the artifacts that you're pushing across. And so that's a gate. And I know gates are annoying, but that potentially would be a gate that for you would mitigate this risk and give you more confidence that you can run faster, and they check the versions that you're using of the open source project to make sure that, you know, you haven't inadvertently gone too forward or too backward. But again, it doesn't solve doesn't solve the merge issue. I get that. I don't think there is. I really don't think there is a good option for that, other than, you know, containerization helps, but no.
Well, in my case, I think is just making sure that the bug fix didn't just live on my code, but I put it back into the open source project. And then as somebody else solves that same bug in a different way, I don't have to now untangle these two solutions, basically.
Another example related but different is people pulling artifacts from public repos. So not looking at the code repositories itself, they're pulling down Docker images from public repos. And they do that accidentally in the build process for production. So private repos for your artifacts, absolutely critical, because you can't do that. You can't pull down from public repos without having vetted images. That's very dangerous. Yeah, that was a half answer. I'm sorry about that.
No, I think that was a great answer. Thank you so much, Chris. Unfortunately, we're out of time, but I really appreciate
Thanks, Justin.
your talk, and thank you for getting up really early this morning, all the way from Colorado to be with us live. I really
woke me up. I'm good. Thanks everybody for joining. It was great. Have a great day.
Cheers. You have a great day as well. We'll see you later for the next talk. Enjoy the conference.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.